Hello all, as we continue our look into polynomials, and with this video we're going to look at division of polynomials using both long division and equating coefficients. The first one we're going to get into is long division, and then we'll use where we looked at back in exercise 6A. We did look at equating coefficients, but we'll look at it to how we can actually divide polynomials. Most of the ones we're going to be dealing with are actually going to be cubics and quartics. We're going to be doing division of them, but just to start with our more simple example, we're going to start with the division of a quadratic. So division of polynomials is we take one polynomial, divide it by another polynomial. So let's get started straight away with an example. So divide the polynomial x squared minus 5x plus 7 by x minus 2. So that's the division we need to do. First thing we want to do is you want to set it up like a long division like you would have done back with large numbers. So we set it up like this. We're dividing x squared minus 5x plus 7 by x minus 2. And I've put the x there in red because that's going to be a key, term. We're going to be using this over and over again in processes, and you'll see, especially in cubics and quartics, it gets used, 4 times. But that's the first thing we do. We're doing, if we wanted to write this as a fraction, we could also write it like that. That's what we're trying to do. So x squared minus 5x plus 7 divided by x minus 2. Now the very first thing we do is we take this number out the front, or a term I should say, out the front, and we divide it by the first term inside the division. So in this case we do x squared divide by x, and that gives us an x, and that's what we put up the top. So to get that, we've done x squared divide by x, and we put it there. What we do from here is we now multiply it by everything at the front, and we're going to write it in brackets here. So we get x times x is x squared, and then x times 2 is negative 2x. So we've gotten to this stage. And I should have prefaced this saying, this has lots and lots of steps. So if you need to pause, rewind, go back, or maybe let this all run through once so you get the overall idea of where we're going, and then go back and rewatch it from the start again, that will might help with working through this. So we've done that. What we're going to do now is we're actually going to subtract this new line that we put in here from everything above. So we're going to take away everything in this blue brackets from what's inside the divisor above. So x squared take away x squared is 0. Negative 5x take away negative 2x is negative 3x. So just to be clear, that's negative 5x take away negative 2x. Taking away, and then we've got the negative there, is negative 3x, and then since there's nothing here, it's effectively a 0, so it's 7 take away 0, so we can bring that 7 down, or just think about 7 take away 0, and we get to there. Once we've gotten to this stage, we just repeat that whole process again. Come back to the very start using our key term. How many times can that go into negative 3x? Well, that can go in negative 3 times. So we've gone into that. That's how we've gotten those ones. Okay. How many times can x go into negative 3x? Well, it can go negative 3 times. Now we've got that number up the top. We're going to multiply it by both of those numbers, and we're going to put it in here. Okay, so negative 3 times by x is negative 3x. And then negative 3 times by negative 2 is plus 6. And we're going to do the subtraction again. So negative 3x take away negative 3x is 0. And 7 take away 6 is 1. And that's what we get. Now you can try and do the process again. So that's our number. How many times can x go into 1? Well, it can't. We can't divide 1 by x, so that's it. We're stuck. So what we actually have is the the technical names for everything here is the dividend. What we're trying to divide by is x. What we're trying to divide is x squared minus 5x plus 7. The divisor, so what we're dividing by, so let me put up here, this is the dividend, and this is the divisor. And what we're going to get is the quotient, which is the answer, which was this bit up here. This is the top bit. That's effectively our answer. But then anything left over is called the remainder. Okay? Because we can't divide that by x. We can't keep putting something up here at the top. So we're stuck with that plus 1 at the end. So that's our remainder. So what's the answer to x squared minus 5x plus 7 divided by x minus 2? Well, the answer to that is x minus 3 up the top, which was the quotient. Let me make sure I spell that right. Plus the remainder. So the other way we can write it, and the best way to write it, the best way to write it is we've started with some polynomial. We've divided it by the divisor, but we can rewrite this as that is equal to x minus 2, what we were dividing by, times by our answer plus our remainder. So the other way we could have rewritten this was p of x on we were dividing by d of x, and we got q of x plus, and this is the weird bit, the remainder is technically on what we were dividing by. This form here makes a little bit more sense. Okay. Our original is equal to what we're dividing by, answer. Why's my pen stop working? Maybe PowerPoint's frozen. Yeah. Answer plus remainder. Which makes sense. Yeah. Some original thing is equal to what we're dividing by times by its answer plus the remainder. So that's how we do long division. So there's a lot in there. And that was just dividing by a quadratic. If we did a cubic, there would be repeat that whole process one more time. If we did that for a quartic, we'd be repeating that process another time. So there'd be 4 repetitions. So let's do a cubic now. So we're doing x cubed minus 5x squared plus 3x take away 2 divided by x minus 3. So just to be clear, what we're trying to do, plus 3x minus 2, and we're trying to divide by x minus 3. So we set it up as a long division, and again our x out the front is our key term. So the very first thing, how many times can x go into x cubed? Well, we can get, or if we divide x cubed by x, we get x squared, so we put that up the top. We're now going to multiply it by everything in front, so x squared times by x is x cubed, x squared times by negative 3x is negative 3x squared. And now we're going to do the subtraction. X cubed take away x cubed is 0. Negative 5x squared take away negative 3x squared. And this is where it's really handy to put the minus sign in brackets here so you don't forget the signs, don't make mistakes with sign. We get negative 2x squared, and then everything else just comes down, because that's effectively 0 there and 0 there. Comes down. We repeat the whole process all over again. Divide negative 2x squared by x, and whatever we get, we're going to put up the top, and that would be negative 2x. That is coming from negative 2x squared divide by x. Oh, that leaves us with negative 2x. Repeat the process. We're going to multiply it by everything out the front. So negative 2x times by x is negative 2x squared. Negative 2x times by negative 3 is plus 6x. And then we do the subtraction again. So we're going to get 0 there. 3x take away 6x is negative 3x. and then we bring down the 2, because again, we're effectively taking away 0. Repeat the process now a third time. Negative 3x divided by our x, which is out the front, gives us negative 3. And then for a last time, I'll use black arrows, multiply it by everything out the front. We're going to put that on there. So negative 3 by x is negative 3x. Negative 3 by negative 3 is positive 9. Do the subtraction and we get negative 11 left. Now again, we can try negative 11 divided by x. What is it? Well, we can't do that. So that's where we stop. That's where we end. So what do we have? We want to look at the dividend, which we were trying to divide. The original polynomial is x cubed minus 5x squared plus 3x minus 2, obviously. What we were trying to divide by, the divisor, is x minus 3. The quotient, so sort of our answer, is x squared minus 2x minus 3 up here. Okay, and then we clearly have a remainder of 11. So how can we write this? Well, our original polynomial is equal to what we were trying to divide by times by our answer plus our remainder. So we can write this as what we're trying to divide by times by answer plus our remainder, which was negative 11. And so we've done the division. Now what we would do from here, and we do all these long division because we're trying to factorize the polynomials. We're trying to get it into set form. So for a cubic, we're trying to get it into minus e minus f minus g. We're trying to get it into something like that, where we can read all 3 intercepts of the cubic. So that's the whole reason we're going through all this, is to be able to do that. So from here, we've got one of the factors out. What we need to do is now factorize this quadratic. Now, how would we do that? Well, we can use inspection, we can use cross method, we can use quadratic formula. You can now try and do long division of it, to try and divide it by something. And there's many ways to factorize that, but that's the process. Rightio. Last example, so divide the polynomial x cubed minus 2x squared plus 3x minus 2 by, and this is a little bit different, this one. It's x squared minus 4. So we've got an x squared, so we've got to be careful with our process. Oh, that one doesn't work by steps, so I might actually just write this out. So we're doing x squared minus 4, and the original polynomial is x cubed minus 2x squared plus 3x minus 2. Rightio. So the x squared is our magic term, so x cubed divided by x squared, what does that give me? Well, that leaves me with an x, so now I'm going to multiply that by everything in front, and I'm going to get negative, I'm going to get x cubed, x times by, so I get negative 4x. Okay, so I'll just write it here briefly, but negative 4x, but that's beneath my x squared term. That's the subtraction I can't do. So what I technically need to do is put it under the term I'm going to be able to subtract it from, and just put a placeholder 0 in there, and I have my sort of placeholder 0 out the end. So I've done that. Now I'm going to do that subtraction. So x cubed take away x cubed is 0. Negative 2x squared take away the 0. It just stays the negative 2x squared. 3x take away negative 4x. So taking away a negative is like adding, so that turns into plus 7x. Negative 2 take away 0 is just negative 2. I've done that. Now I'm going to repeat the whole process again. So x squared. So I have my negative 2x squared. Divide by x squared out the front, that's going to give me negative 2. Now I'm going to multiply that by everything in front. So I get negative 2 times by x squared is negative 2x squared. Sorry. Negative 2 times by negative 4 is 8. So again, I could write plus 8 there, but that's under an x term. So I don't want to do that. I want to put it over here under the constant and put a plus 0 there. Now let's do that subtraction. So we get negative 2x squared take away negative 2x squared is 0. 7x take away 0 is 7x. Negative 2 take away 8 is negative 10. So we get to this stage. Now we try and do the same thing again. Use my x squared, the magic term out the front. Can I divide 7x by x squared? I can't. And this is a sort of weird thing. This is what happens when we're dividing by a quadratic is, well, this linear term cannot be divided by x squared. We can't do 7x divided by x squared and get sort of something nice to go up here. So that's as far as we can go. This is actually a remainder. So, as always, our original polynomial is equal to the thing that we're trying to divide times by answer plus remainder. So we get, in this case, this original polynomial when divided by x squared minus 4. We can rewrite this as x squared minus 4, our answer which was just x minus 2, and then our remainder was plus 7x minus 10. So that's it for our examples for long division. Like I said, you can go back and re-watch them. There's also heaps of YouTube videos on how to do this as well. But what we'll go on to now is how to use equating coefficients quickly to do a division. Or not so much do the division, but find out, write it, to be able to write it in this form. We can use equating coefficients to write it in that form. And then if we interpret that form, we always know that this thing here, well, that was, I guess, answer, and with our remainder. With all of these, there'll be times when where we keep going and this answer here becomes 0, which is fine. That just means there's no remainder, there's nothing left over. And that's really nice. That's actually what we prefer if we're trying to factorize something and get it into intercept form. We actually need no remainders. So that's completely fine if you get a 0 there and it's no remainder. Right, equating coefficients. Divide this example. Here's our p of x, our original polynomial. And we're trying to divide it by, this is our divisor here. That's what we're trying to do. Now, we know from all those previous examples, if we divide a cubic by a linear, we get, well, the thing we're trying to divide by, we get our answer, importantly, here's our quotient, our answer, and then we get some remainder on it. Now, when we divide a cubic, x cubed term by a linear, well, that means this has to be an x squared. So we know our quotient answer is going to be some form of quadratic. So recognize that. We know it's going to be of some form of ax squared plus bx plus c, and then some remainder on the end. And so we can expand this whole thing here, which is what we're doing here. We're expanding. Here we rearrange, or we are grouping terms. You can see there's my only x cubed term. These are my x squared terms. These are my x terms, and then these are my constants at the end. And then I can factorize each of those. I'm factorizing. So I can then equate from my original polynomial. My 2a, because that's the only x cubed term, must be the same as that 2. This 2b minus a must be the same as this negative 2, because that's what's in front of the x squared. This negative b plus 2c must be the same as this 5, because that's the only thing in front of an x term. And then the negative c plus r must be the same as this plus 3. They must be equivalent. And so working through them, we can solve the first one. that's that first equivalence. 2a is equal to 2, therefore it's pretty obvious that a must be 1. We can then work on the second one, the 2b minus a, this was a, which we know is now 1. Write that there quickly. We've started with that is equal to that -2. We know a is 1, so we can then solve and we get our b, and we just keep repeating that process over and over. We have half plus 2c equals to 5. We're using this one here and we substituted in our b. We solve to get our c is equal to 9/4, and then we can do constant color. We can do the constants at the end, equate them, solve for r. So we can write our final answer, or our original polynomial, is equal to what we tried to divide by the quotient. We figured out we can substitute these. We've substituted a, b, and c back into our original quotient. Way back up there, we've substituted what we figured out, a, b, and c, into there, and then write our remainder on the end. So that's how we can use equating coefficients. So let's do one example, and then the rest of the examples will be the initial practice in class that you can go over and chat to each other about. Right here, so by equating coefficients, write x cubed minus 17x plus 54x minus 8 in the form of x minus 4 multiplied by something plus r. So this is that equating coefficients. And q of x, it needs to be a quadratic, and we know that because we're starting with an x cubed, we're dividing by an x, that means we're going to have some x squared term. So let's do that. X cubed minus 17x squared plus 54x minus 8 will be equal to x minus 4 multiplied by some quadratic, and we can't forget the a at the front, plus c plus some remainder. So I'm just going to expand that. So to expand, we have to multiply everything in the first bracket by everything in the second bracket. So we get ax squared plus bx squared, ax cubed, plus bx squared plus cx minus 4ax squared minus 4bx minus 4c, and we have our plus r on the end. Now I'm going to start grouping terms. The ax cubed is my only x cubed term, bx squared and negative 4ax squared. I get ax cubed plus bx squared minus 4ax squared. I'm going to group the linear terms now. So plus cx minus 4bx, and then I have my constant terms on the end, which is just minus 4c plus r. Now I want to factorize those, so take the x squared out, I get b minus 4a. I take the x out, I get c minus 4b, and then the constants at the end. So I can now equate coefficients. I have my x cubed, so from that I have ax cubed is equal to x cubed, which is quite obvious that a needs to be equal to 1. My next one, I have negative 17x squared is equal to b take away 4a x squared. So it's obvious from that that negative 17 needs to be equal to b minus 4a. And we figured out a was 1, so we get negative 17 is equal to b minus 4. So we get, add the 4 over there, so we get negative 13 is equal to b. And from the linear term, we get 54 is equal to, 54x is equal to c minus 4b x. It's obvious from that 54 must be equal to c minus 4b. And we already figured out b was negative 13, so we get 54 is equal to c, take away 4 by negative 13. 54 is equal to c plus 4 by 13. Just going to do it over here quickly. 4 3s are 12. Carry the 1, 4 1s are 4. 52. Take that away. We get 2 is equal to c. And lastly, equating our constants, we get negative 8 is equal to negative 4c plus r. So we get negative 8 is equal to negative 4 by 2 plus r. We get negative 8 is equal to 8 plus r. So r is equal to 0. So we actually get no remainder in this. That's really nice. So we can rewrite our whole original polynomial. I'm just going to write that as p of x is equal to x minus 4 bracket, and I'm writing this quadratic now up here, and I'm just substituting the a, b, and c I figured out. A was 1, so that's just x squared. B was negative 13, so minus 13x. C was 2, and our remainder is 0, so we can actually just leave it like that. And now from there we could try and factorize that quadratic by inspection, completing the square, quadratic formula, whatever you like. That will work. But that's it. There's a sort of flowchart that breaks down the ideas of how we'll try and factorize. So if we're given we've started with quadratics as the easiest one, inspection, cross method, common factor, completing the square, quadratic formula. Now coming to cubics, and we'll just look at those for now. You can group via inspection, but it needs to be really obvious to stand out. But at the moment, we've just shown you how to do long division. If we're giving you one of the factors already, you're going to divide it. You'll get some x minus whatever, and then you'll get some quadratic. And now to factorize this quadratic, you use your quadratic bit, and you'll eventually be able to get in the form of x minus e, x minus f, x minus g, working through your flowchart. So we've done that. We've also shown you briefly how to do equating coefficients. What we still need to show you is how do you get that original factor. So here we already told you the x minus 4. So this thing called factor theorem. So that's where we'll be moving towards, is how to figure out what that initial thing we should divide by. That's it for now. I slightly apologize for the long video, but I think having multiple examples is really handy. All the best in class. If you have any questions, feel free to put in the comments below, email, or put on Google Classroom. Have a good weekend.